Welcome to Sleep to Science. Tonight, we're taking a journey through our solar system, the cosmic neighborhood we call home. When you step outside and glance up at those wandering points of light, they seem so peaceful, almost like decorations sprinkled across a velvet backdrop. What's actually happening up there? Those innocent-looking dots represent 8 wildly different worlds, all locked in eternal servitude to a nuclear monster. At the center sits a furnace that could swallow 1,000,000 Earths without gaining much weight. This stellar dictator has been ruling its planetary subjects with absolute power for 4.6 billion years. Each world tells a dramatically different story. Some freeze in permanent winter. Others melt under blazing heat that turns metal into vapor. One planet rains sulfuric acid. Another hosts storms larger than our entire planet. These storms have been raging for centuries. Yet somehow, in this cosmic chaos, one world developed perfect conditions. Oceans, continents, and breathing creatures. Tonight you'll discover how this thermonuclear tyrant maintains its grip. 8 completely different planetary personalities. From Mercury's hellish temperature swings to Neptune's diamond raining storms. Each shaped by their unique relationship with our solar system's burning overlord. So settle in. Before we begin, leave a quick note in the comments, where you're listening from, or one thought you're carrying tonight. I read them, and they genuinely help shape future journeys. If you'd like more nights like this, subscribe, only if you enjoy these late-night journeys. Now let's begin. Ancient people looked up and saw wandering stars. They called planets wanderers because these bright dots drifted among the fit's stellar background. Even brilliant minds like Aristotle assumed we lived in a diverse cosmic community. Different celestial objects coexisted as independent residents of space. This comfortable assumption would prove hilariously wrong. Galileo aimed his telescope at Jupiter in 1610. He spotted 4 tiny dots orbiting the giant planet like miniature companions. This discovery cracked open humanity's cosmic perspective entirely. Those dots weren't independent celestial citizens. They belonged to Jupiter. They obeyed Jupiter's gravitational commands. The universe operated more like a hierarchy than a democracy. Modern measurements revealed the shocking truth about our cosmic neighborhood. We don't live in a diverse stellar democracy at all. Everything visible in our night sky belongs to one massive gravitational bully. Our sun doesn't just sit at the center of this collection. It literally holds 99.86% of all the matter in our solar system. Talk about wealth inequality on a cosmic scale. Picture this cosmic dictatorship. Our sun weighs 330,000 times more than Earth. Jupiter, our solar system's heavyweight champion, represents barely 1,000th of the sun's mass. Mars could fit inside the sun 7 million times over. All 8 planets combined, plus every moon, asteroid, and cosmic pebble still account for less than 0.2%. The neighborhood's total matter belongs almost entirely to our stellar overlord. This stellar tyrant rules through pure gravitational force. The sun's immense mass creates an invisible prison. It dictates every object's behavior. Mercury races around its burning master in just 88 days because solar gravity grips it tightest. Neptune sits in cosmic exile at the Empire's edge. It takes 165 Earth years to complete one slow, distant lap around its nuclear overlord. No planetary parole hearings. No escape velocity. Just eternal orbital servitude to our thermonuclear dictator. Here's what makes this cosmic tyranny truly extraordinary. Despite containing virtually all the power in our stellar empire, the Sun distributes life-giving energy with remarkable precision. It bathes Mercury in furnace-level heat while barely warming distant Neptune. This same nuclear monster that could instantly vaporize any planet also provides exactly the right warmth. Earth's oceans stay liquid. Absolute power combined with perfect environmental control. What if I told you that right now you're experiencing the end result of an 8-minute and 20-second journey? That journey began 93 million miles away. As you read these words, photons are streaming from our star's blazing surface toward your exact location. Each ray of light races through vacuum at about 180,000 miles per second. It is the cosmic equivalent of express delivery from a thermonuclear furnace. That 93 million mile gap represents one of the universe's most crucial measurements. Scientists call this distance one astronomical unit. It serves as the cosmic yardstick that separates paradise from hellscape. This isn't approximate positioning. Earth's orbital distance requires precision that would impress a Swiss watchmaker. Move our planet just 5% closer to the Sun. Earth becomes Venus, a furnace world where lead melts in the shade. Oceans boil away into space. Atmospheric pressure crushes everything into pancakes. Shift us 5% farther from our stellar master. Earth becomes Mars, a frozen wasteland where water turns to permanent ice. Atmospheres gradually leak into space like air from a punctured balloon. Astronomers have discovered thousands of planets orbiting other stars. Most fail this cosmic Goldilocks test spectacularly. Some worlds sit so close to their parent stars that daytime surfaces melt into oceans of molten rock. Others orbit so far away that nitrogen freezes solid. It falls to the ground like snow. One planet rains diamonds. Another has winds that could shred titanium. The universe seems determined to create the most extreme planetary conditions imaginable. Earth alone nailed this cosmic positioning exam. We occupy what scientists call the habitable zone. It is that narrow orbital band around a star where liquid water can exist on a planet's surface. Not too hot, not too cold, just right for chemistry that creates and sustains life. This perfect positioning creates an even more extraordinary phenomenon. Seasonal stability has persisted for billions of years. Earth maintains its 93 million mile orbital distance with remarkable consistency. We vary by only 3 million miles between closest and farthest approaches to the Sun. The sunlight that warmed the first primitive organisms 3.5 billion years ago made exactly the same 8-minute journey, from precisely the same stellar distance. Every moment of life on Earth connects through this unwavering cosmic clockwork. Try to imagine hosting the universe's most dysfunctional family dinner. 8 siblings with completely opposite personalities sit around the same stellar table. One burns everything it touches. Another freezes solid. A third one spins sideways like it's having a cosmic tantrum. Welcome to our solar system family reunion. Mercury plays the role of hyperactive youngest sibling. It zips around the Sun so fast that its year lasts only 88 Earth days. But here's the cosmic joke. Mercury's day lasts longer than its year. This speed demon takes us 76 Earth days to spin once on its axis. Imagine celebrating your birthday twice before seeing one sunset. Mercury doesn't just have mood swings. It has temperature swings that would melt lead at noon and freeze carbon dioxide at midnight. Venus serves as the toxic sibling nobody wants to visit. Beneath its beautiful appearance lurks a planetary psychopath. Surface temperatures reach 900 degrees Fahrenheit. hot enough to melt zinc. Its thick atmosphere creates pressure 90 times stronger than Earth's, like being crushed under 3,000 feet of ocean water. And it rains concentrated sulfuric acid. Venus represents what happens when the greenhouse effect completely loses control. Mars earned its reputation as the eccentric relative who used to be normal. Billions of years ago, Mars had flowing rivers, possibly vast oceans. Ancient riverbeds and lake beds cover its surface like fossil evidence of a wet, warm past. Now it's a frozen desert with an atmosphere thinner than Earth's at 100,000 feet altitude. Mars serves as a cautionary tale about losing your atmospheric protection. The outer planets form an entirely different category of weird. Jupiter weighs more than all other planets combined. It could contain 1,300 Earths inside its massive frame. This gas giant operates like a cosmic vacuum cleaner. It protects Earth by capturing dangerous asteroids and comets. Jupiter's Great Red Spot represents a storm larger than our entire planet. The storm has been raging for over 400 years. Saturn brings the bling with its spectacular ring system. These aren't solid hoops but countless ice chunks. They range from dust particles to house-sized boulders. Saturn's density is so low it would float in water, if you could find a bathtub large enough. Its moon Titan has thicker atmosphere than Earth, plus lakes filled with liquid methane. The ice giants Uranus and Neptune occupy the solar system's frozen suburbs. Uranus rotates on its side like it got knocked over during planetary formation. Neptune experiences winds reaching 1,200 miles per hour, fast enough to circumnavigate Earth in 20 hours. Both worlds rain diamonds in their deep atmospheres due to extreme pressure conditions. Every great family story begins with humble origins. Our solar system started as absolutely nothing special. Just another anonymous cloud of gas and dust. It drifted through interstellar space 4.6 billion years ago. No sun, no planets, no rocky moons, nothing but cosmic ingredients waiting for the right moment to transform. What triggered this transformation? A nearby stellar explosion probably provided the cosmic kick our nebula needed. This supernova shockwave compressed our lazy gas cloud until gravity finally gained the upper hand. The collapse began slowly at first, then accelerated as material packed tighter and tighter into the cloud's central region. Physics demanded that this spinning cloud flatten into a disk. Material spiraled inward toward the center. The center accumulated mass fastest. Temperature and pressure climbed as gravitational compression heated the core beyond imagination. When central temperature reached 18 million degrees Fahrenheit, hydrogen nuclei began fusing into helium. Nuclear fusion ignited. Our sun was born. The stellar furnace that would dominate our neighborhood for billions of years began its thermonuclear career. Meanwhile, the remaining disk material organized itself into planetary construction zones. Close to the newborn sun, only rocky materials could survive the intense heat. Metals and silicates condensed into solid grains. These particles stuck together through countless collisions over millions of years, slowly growing from pebbles to boulders to mountain-sized planetesimals, eventually forming the rocky planets Mercury, Venus, Earth, and Mars. Farther from solar heat, water could freeze into ice. This created much more raw material for planet building in the outer regions. Ice-rich planetesimals grew massive enough to gravitationally capture hydrogen and helium gas directly from the surrounding nebula. Jupiter and Saturn became gas giants by accumulating vast gaseous envelopes around their solid cores. The construction process was violent and chaotic. Planetary embryos collided and merged in cosmic train wrecks. These impacts reshaped entire worlds. Earth experienced an impact so massive it blasted material into orbit. That material eventually formed our moon. Mars lost much of its atmosphere to space. Venus developed its runaway greenhouse effect. Yet somehow, through all this cosmic chaos, our solar system family emerged. 8 distinctly different personalities orbit the same stellar patriarch. This formation story explains why our planetary family displays such incredible diversity. Distance from the Sun determined each world's basic character. Close-in planets became small and rocky. Distant worlds grew large and gaseous. Temperature gradients, available materials, and gravitational interactions sculpted 8 unique worlds, all from the same cosmic starting ingredients. Meet Mercury, the solar system's most bipolar resident. This tiny world experiences the most extreme mood swings imaginable. At noon, surface temperatures climb to 800 degrees Fahrenheit, hot enough to melt lead, zinc, and tin into puddles. 6 months later, Mercury spins its other face toward the Sun. The same locations plummet to minus 300 degrees Fahrenheit, cold enough to freeze nitrogen solid. These aren't seasonal changes. This is Mercury's daily reality. The planet lacks any meaningful atmosphere to distribute heat around its surface. No greenhouse effect. No thermal regulation. Just naked rock absorbing and radiating solar energy with the efficiency of a cosmic toaster oven. Imagine living in a place where your backyard could melt copper pennies. Meanwhile, your front yard freezes solid simultaneously. How does one small world create such temperature extremes? Distance from the Sun plays the obvious role. Mercury orbits just 36 million miles from our star. That's roughly 1/3 of Earth's distance. At that range, solar radiation arrives with punishing intensity. Each square meter of Mercury's surface receives 10 times more solar energy than Earth. The midday sun appears 3 times larger in Mercury's sky than it does from our comfortable suburban distance. But proximity alone doesn't explain Mercury's temperature chaos. The planet's lack of atmosphere creates the real problem. Earth's atmosphere acts like a planetary blanket. It distributes heat from day to night and pole to equator. Mercury has essentially no air to speak of. Its extremely thin atmosphere contains less gas than the best vacuum chambers on Earth. This cosmic nakedness means heat absorbed during Mercury's 88-day-long noon gets radiated straight back to space. It happens during its equally long night. The result: Mercury experiences the largest temperature range of any planet in the solar system. That is a temperature swing of 1100 degrees between day and night. That's like switching between the inside of a pizza oven and the surface of liquid nitrogen every 6 months. Venus actually maintains hotter average temperatures due to its thick greenhouse atmosphere. But Mercury wins the prize for the most dramatic temperature personality disorder. These extreme conditions make Mercury one of the most hostile environments imaginable. Any water would instantly boil away on the day side and freeze solid on the night side. Metals expand and contract so violently they would crack and shatter. The surface literally bakes and freezes in endless cycles. These cycles would destroy any human-made materials within days. Mercury represents what happens when a world loses atmospheric protection while living next door to a nuclear furnace. Here's something that will scramble your brain. Mercury operates on the universe's most confused calendar system. This speed demon races around the Sun faster than any other planet. It completes one orbit in just 88 Earth days. But Mercury spins so slowly on its axis that its day lasts 107.66 Earth days. Mercury celebrates 2 birthdays before witnessing sunrise. Let that sink in. On Mercury, you'd experience your new year twice before seeing the sun set and rise again. This creates a cosmic absurdity where Mercury's year is exactly half as long as its day. It's like having a calendar where February lasts longer than the entire rest of the year combined. Time gets seriously weird when you're the solar system's closest planetary neighbor to a gravitational monster. Why does Mercury's rotation move at such a leisurely pace? The Sun's enormous gravitational influence has gradually slowed Mercury's spin over billions of years. This happens through a process called tidal locking. The same force that keeps our moon showing Earth the same face has been steadily breaking Mercury's rotation. The planet hasn't completely locked one face toward the Sun yet, but it's getting close. This creates Mercury's strangest feature. The planet experiences a 3-to-2 spin orbit resonance. For every 2 trips around the Sun, Mercury rotates exactly 3 times on its axis. This means the same hemisphere doesn't always face the Sun. Instead, Mercury alternates which side bakes in solar radiation during successive orbits. The planet essentially takes turns roasting its northern and southern hemispheres. It's like a cosmic rotisserie chicken. Imagine living on such a world. You'd plan your life around 88-day seasons that determine whether you're on the day side or night side. Sunrise would arrive once every 76 days. But when it came, the sun would hang in the sky for months. The sun would also appear to move strangely across the sky. This is due to Mercury's elliptical orbit and slow rotation. Sometimes the sun would even appear to reverse direction. It would travel backward for several days before resuming its normal east-to-west motion. This temporal chaos makes Mercury the most schedule-confused planet in our neighborhood. Its calendar system would drive any civilization to insanity. Mercury proves that living too close to a massive star doesn't just create temperature problems. It completely breaks your relationship with time itself. The planet serves as a cautionary tale about what happens when gravitational forces start messing with your daily routine. Mercury's surface tells the violent story of a world with no bodyguards. Unlike Earth, which enjoys atmospheric protection that burns up most incoming space debris, Mercury stands completely naked against cosmic bombardment. For 4 billion years, asteroids, comets, and meteorites have been using this defenseless planet for target practice. The result looks like the universe's most extreme shooting range. Every square mile of Mercury's surface bears the scars of celestial violence. Craters cover the landscape so densely they overlap like cosmic N. Some craters stretch over 100 miles across. They were created by asteroid impacts so powerful they would have shattered continents on Earth. The largest impact basin, called Kelloris Basin, spans 960 miles in diameter. That's roughly the distance from New York to Chicago blasted into a single circular scar. Earth receives roughly the same cosmic bombardment as Mercury. The difference: our planet fights back. Earth's atmosphere creates a protective shield that burns up 99% of incoming space rocks before they reach the ground. We see these atmospheric victories as shooting stars. Most meteorites that survive atmospheric entry are small enough to hold in your hand. Mercury gets hit by everything the universe throws at it with full force. The absence of atmospheric protection means even tiny pebbles become deadly projectiles on Mercury. A grain of sand traveling at 20 miles per second hits Mercury's surface with the energy of a small bomb. Larger rocks create explosions that would dwarf nuclear weapons. The biggest asteroid impacts generate so much energy they melt rock for hundreds of miles around the impact site. Mercury's surface preserves this cosmic violence in permanent geological scars. These relentless impacts have pulverized Mercury's surface into a layer of fine dust and rock fragments. It is several yards deep. Scientists call this impact debris regolith. It covers the planet like cosmic flour created by billions of years of celestial hammering. Walking on Mercury would feel like trudging through extremely fine sand. It is created entirely by exploding space rocks. Mercury also lacks the geological activity that would erase impact craters over time. Earth constantly renews its surface through plate tectonics, volcanic activity, and erosion. Mercury is geologically dead. Once a crater forms on its surface, it remains visible for billions of years. The planet serves as a permanent museum of solar system violence. It preserves impact scars dating back to the earliest days of planetary formation. This cosmic bullet-riddled landscape makes Mercury one of the most dangerous places to visit in our solar system. Even with a spacesuit, you'd be gambling with meteorite impacts. These impacts could instantly vaporize you. Mercury represents what Earth would look like if we lost our atmospheric protection. A world where space rocks rain down like cosmic bullets with nothing to stop them. Mercury earned its reputation as the solar system's most frustrating celestial hide-and-seek champion. Most people have never noticed it in the night sky, even though it's technically visible to the naked eye. This elusive world stays so close to the sun that it spends most of its time hidden in solar glare. The problem stems from Mercury's intimate relationship with our star. The planet orbits so close to the sun that it never strays far from our star's position in the sky. That means Mercury is usually lost in the overwhelming brightness of daylight. Even when the planet rises above the horizon, it often does so just before sunrise, or it sets shortly after sunset, always lurking near the sun's blinding presence. When Mercury does become visible, it appears only during specific windows. These happen during twilight, before the sky goes fully dark or fully bright. Mercury can be spotted low on the horizon as a small bright dot, but it never climbs high overhead like other planets. These viewing opportunities last at most an hour or two before Mercury either sinks below the horizon or disappears into the sun's glow. This creates a strange observational puzzle. Ancient astronomers often thought Mercury was two different objects. One appeared in the morning, the other appeared in the evening. Some cultures even gave Mercury separate names. They assumed the morning star and the evening star were different planets. This confusion persisted until careful tracking revealed that the morning star and evening star were the same elusive planet, playing cosmic peekaboo with human observers. Modern telescopes don't solve the problem easily, because Mercury appears so close to the sun. Telescopic viewing requires looking through thick layers of Earth's atmosphere near the horizon. Atmospheric turbulence blurs the view and reduces clarity. Heat rising from the ground distorts the image like looking through a shimmering mirage. Even the best Earth-based telescopes struggle to reveal Mercury's surface details clearly. This is why Mercury remained mysterious for so long. Venus and Mars reveal their features more readily. Jupiter and Saturn dominate the night sky with their brightness. Mercury stays stubbornly hidden. It guards its secrets behind the sun's glare. It remained one of the least understood planets until space missions could get close enough to see it directly. This observational difficulty also shapes Mercury's cultural footprint. Many people can name the bright planets they see easily: Venus, Mars, Jupiter, and Saturn. Mercury often gets forgotten, not because it isn't there, but because it requires patience and perfect timing to spot. Mercury remains the most underappreciated naked-eye planet precisely because it works so hard to stay hidden. Mercury seems like the last place you'd expect to find ice. This planet lives next door to a nuclear furnace. Daytime temperatures can melt lead, yet scientists discovered something that sounds impossible. Mercury has water ice, and not just tiny traces. It has substantial deposits hidden in permanent shadow near its poles. How can ice survive on a world where the sun can bake rock into glowing heat? The answer lies in Mercury's strange geometry. Unlike Earth, Mercury has almost no axial tilt. Its spin axis stands nearly upright compared to its orbit. This means the sun always stays low on Mercury's horizon near the poles. It never rises high enough to shine into some deep craters. At Mercury's north and south poles, certain impact craters contain regions of eternal darkness. Sunlight has not touched these crater floors for billions of years. Temperatures in these shadowed pockets stay around -300 degrees Fahrenheit, cold enough to preserve ice indefinitely. These craters function like natural freezers, protected from the sun's direct heat. Scientists first suspected polar ice in the 1990s. Radar observations revealed bright reflective patches at Mercury's poles. These patches behaved like water ice. Later, NASA's MESSENGR spacecraft confirmed the discovery. It mapped Mercury's polar regions in detail. It found that the radar-bright areas aligned perfectly with permanently shadowed crater floors. The ice likely arrived by the same delivery system that brought water to Earth: comets and water-rich asteroids. Over billions of years, impacts deposited water molecules across Mercury's surface. Most water molecules would instantly evaporate under solar heat, but some migrated toward the poles. They became trapped in these permanently shadowed craters. Once inside, they froze and accumulated layer by layer. This discovery changes how we think about water in the inner solar system. Even the planet closest to the sun can preserve ice if the conditions are right. It also suggests that other airless worlds might hide water ice in shadowed regions. The Moon has similar permanently dark craters. So do some asteroids. Mercury's polar ice mystery proves that our solar system still holds surprises. Even in the harshest environments, nature finds ways to preserve precious resources. A world that seems completely hostile can still harbor hidden reservoirs. This planet next door to a nuclear furnace contains frozen water, locked away in darkness, waiting in the coldest shadows of the solar system. Venus operates the universe's most effective sauna. This planetary furnace maintains surface temperatures of 900 degrees Fahrenheit around the clock. That's hot enough to melt lead, zinc, and copper into puddles. Even hotter than Mercury despite sitting 25 million miles farther from the Sun. Venus achieved this remarkable feat by perfecting the greenhouse effect with terrifying efficiency. The secret ingredient: carbon dioxide. Lots of it. Venus's atmosphere contains 96% carbon dioxide compared to Earth's measly 0.04%. This creates a greenhouse effect so powerful it traps heat like a planetary pressure cooker. Solar energy enters through the atmosphere, but can never escape back to space. The result is a runaway greenhouse process. It has been cranking up planetary temperatures for billions of years. Think of Venus as Earth's evil twin that discovered steroids. Both planets started with roughly similar size, mass, and distance from the Sun. Earth developed a moderate greenhouse effect that keeps our planet comfortably warm. Venus went completely overboard. Its atmosphere grew so thick with carbon dioxide that it began trapping every photon of solar energy that entered, like wrapping a planet in the universe's most effective thermal blanket. This atmospheric monster weighs 90 times more than Earth's entire atmosphere. The sheer mass of gas pressing down on Venus creates crushing pressure at the surface. Imagine being squeezed under 3,000 feet of ocean water, while simultaneously being baked in an industrial furnace. That's a typical afternoon on Venus. The combination of heat and pressure would instantly crush and incinerate anything humans could build. But Venus's greenhouse nightmare gets worse. The planet's thick atmosphere moves heat so efficiently that day and night temperatures remain virtually identical. The poles stay just as hot as the equator. Summer feels exactly like winter. Venus eliminated temperature variation completely through atmospheric brute force. This planetary sauna never gets a break from its own heat-trapping efficiency. What triggered Venus's greenhouse catastrophe? Early in its history, Venus probably had liquid water oceans just like Earth, but being slightly closer to the Sun caused more water to evaporate. Water vapor acts as a greenhouse gas, which warmed the planet further. This evaporated more water, which created more warming. This positive feedback loop eventually boiled away Venus's entire oceans into space. The planet's surface became so hot that rocks began releasing carbon dioxide. That thickened the atmosphere and completed Venus's transformation into a hellish furnace, one that has been running at full blast for over 1 billion years. Step into the solar system's most hostile spa treatment. Venus doesn't just cook visitors with extreme heat. It also offers crushing pressure therapy and concentrated acid rain facials. This planetary torture chamber combines multiple forms of environmental violence. Violence that would make medieval dungeons seem pleasant by comparison. Let's start with the atmospheric pressure situation. Standing on Venus's surface feels like being crushed under 90 times Earth's atmospheric pressure. That's equivalent to diving 3,000 feet underwater on Earth. The human body would be compressed like an empty soda can under a steamroller. Even the most robust submarine designed for Earth's deepest ocean trenches would crumple like tissue paper. In Venus's atmospheric grip, the acid rain adds a special touch of chemical horror. Venus's upper atmosphere contains concentrated sulfuric acid clouds, the same stuff used in car batteries and industrial processes. These acid droplets evaporate before reaching the surface due to extreme heat. But they create an atmospheric chemistry so corrosive it would dissolve most metals within hours. Breathing Venus's atmosphere would instantly destroy your lungs with acid vapor, while simultaneously cooking them at furnace temperatures. But Venus saves its most diabolical trick for the weather report. Those beautiful yellowish clouds that make Venus appear so bright and lovely from Earth. They're pure concentrated acid floating in the atmosphere. Venus wrapped its hellish surface in a gorgeous toxic veil, one that has been fooling astronomers for centuries. The planet looks like a heavenly beacon while hiding conditions that would make Dante's Inferno seem like a comfortable vacation resort. The atmospheric composition reads like a chemist's nightmare fuel. Sulfur dioxide creates the acid clouds. Carbon dioxide provides the crushing greenhouse effect. Trace amounts of carbon monoxide, argon, and water vapor complete this toxic cocktail. No oxygen for breathing, no water for drinking. Just industrial-strength atmospheric poison under bone-crushing pressure at furnace temperatures. Venus's surface pressure is so intense it would flatten mountains on Earth. The atmospheric weight pressing down on every square inch equals about 1,300 pounds. That's like having a small car sitting on every square inch of your body. Combined with temperatures that melt copper and acid vapors that dissolve steel, Venus created the most comprehensively hostile environment in the inner solar system. Even the most optimistic terraforming dreams crash against Venus's atmospheric reality. You can't just add some air conditioning and call it habitable. The planet's entire atmosphere would need to be removed and rebuilt from scratch. Venus represents what happens when a world develops the perfect combination: heat, pressure, and acid rain. It's a masterclass in how to make a planet completely uninhabitable through pure atmospheric overkill. Picture this cosmic rebellion. Every planet in our solar system received the same basic spinning instructions during formation. Rotate counterclockwise when viewed from above the North Pole. Follow the same directional flow as your orbit around the Sun. Keep things simple and predictable. Venus apparently skipped that orientation meeting entirely. This planetary rebel spins backward compared to every other world in our cosmic neighborhood. Stand on Venus and watch the sun rise in the west and set in the east. That's assuming you could survive long enough to witness a sunrise, which takes 243 Earth days to complete on Venus. The planet rotates so slowly in the wrong direction that its day lasts longer than its year. Venus orbits the Sun in 225 Earth days, but takes 243 Earth days to spin once on its axis. This creates the universe's most confused calendar system, where days outlast years. What caused Venus to become such a cosmic contrarian? Astronomers debate several theories. Maybe a massive asteroid impact knocked Venus sideways during the early solar system's violent formation period. Perhaps gravitational interactions with other planets gradually flipped Venus's rotation over billions of years. Or maybe dense atmospheric tides created by solar heating eventually reversed the planet's spin through atmospheric friction. The most popular theory suggests Venus originally spun normally, but its incredibly thick atmosphere created enough friction to gradually slow and reverse its rotation. Picture trying to spin a ball underwater versus spinning it in air. The dense medium creates drag that fights against rotational motion. Venus's atmosphere is so thick it might have acted like cosmic molasses, gradually breaking and reversing the planet's original spin direction over geological time. This backward rotation creates bizarre effects on Venus's already extreme environment. The sun rises in the west and sets in the east, but so slowly you'd barely notice solar movement during a human lifetime. Venus's retrograde spin also affects how solar heating distributes around the planet, though the thick greenhouse atmosphere equalizes temperatures so effectively that rotation direction barely matters. For surface conditions, Venus's rebellious rotation makes it unique among all known planets. No other world in our solar system chose to spin backward relative to its orbital motion. This planetary nonconformist stands alone as proof that sometimes cosmic formation doesn't follow the rules. Venus reminds us that even in the orderly mechanics of planetary motion, there's always room for one cosmic rebel, one who insists on doing things differently. The backward spin also creates interesting effects for spacecraft navigation. Mission planners must account for Venus's reverse rotation when calculating approach trajectories and landing sites. This adds extra complexity to an already challenging destination. Venus manages to be difficult to visit in every possible way, including the fundamental direction it chooses to rotate. Venus plays the solar system's ultimate catfish. From Earth, this planetary beauty queen appears as the most gorgeous object in our night sky. After the moon and the sun, ancient civilizations called it the morning star and evening star, not realizing they were seeing the same dazzling world at different times. Venus shines so brilliantly it can cast shadows on Earth. It remains visible even in broad daylight if you know where to look. What makes Venus shine like a cosmic lighthouse? The planet reflects sunlight with remarkable efficiency. Those beautiful clouds we admired earlier, the ones made of concentrated sulfuric acid, act like perfect cosmic mirrors. Venus reflects about 70% of incoming solar radiation back to space. Compare that to Earth, which reflects only 30% of solar energy. Venus literally gleams like a polished pearl floating in space. This incredible brightness has made Venus humanity's favorite planetary pin-up since civilization began. The planet appears as either the brightest star in the eastern sky before sunrise, or the brightest star in the western sky after sunset. Never both on the same night, since Venus orbits closer to the Sun than Earth does. Ancient astronomers thought they were seeing two different celestial objects, until they realized the morning and evening stars were the same wandering world. Venus reaches maximum brightness when it appears as a thin crescent viewed from Earth. This seems counterintuitive. Shouldn't a full Venus appear brighter than a crescent Venus? But geometry trumps logic here. When Venus shows its full face to Earth, the planet sits on the far side of the Sun, at maximum distance from us. When Venus appears as a slim crescent, it's much closer to Earth, despite showing less illuminated surface area. The closer crescent outshines the distant full disk. At maximum brilliance, Venus shines 16 times brighter than the brightest star in our night sky. Bright enough to read by on a moonless night. Bright enough to cast distinct shadows. Bright enough to spot during daylight hours if you know exactly where to search. Venus can even trigger UFO reports when atmospheric conditions make it appear to flicker or change colors near the horizon. This planetary spotlight has inspired more romance, poetry, and mythology than any other celestial object except the moon. Venus earned names like the goddess of love and beauty across multiple cultures, all because of those gorgeous reflective clouds. Clouds that hide one of the most hellish environments in the solar system. Venus proves that sometimes the most beautiful exteriors conceal the most deadly secrets. This cosmic beauty queen maintains her stunning appearance while operating a furnace that would instantly vaporize any suitor brave enough to visit. The Soviet Union decided to visit Venus in the 1960s. With the confidence of engineers who had never met a planetary environment that could defeat good communist engineering, they were about to receive an extremely expensive education in the limits of human technology when confronted with conditions designed to destroy spacecraft as efficiently as possible. The first attempts at Venus exploration read like a comedy of cosmic errors. Early Soviet probes either missed the planet entirely or lost contact during the journey. When Venera 1 launched in 1961, it went silent after a week in space. It sailed past Venus without sending any data back to Earth. The Soviets had successfully built a very expensive paperweight, one that would orbit the Sun forever while ignoring its primary target. But Soviet engineers are remarkably persistent. They kept building stronger, more heavily armored spacecraft, designed to survive Venus's hostile environment. Think of it as spacecraft evolution through planetary natural selection. Each new probe lasted slightly longer than its predecessor. Before Venus's combination of heat, pressure, and acid vapor found a way to destroy it, Venera 7 finally achieved the first successful planetary landing in 1970. It transmitted data for exactly 23 minutes before succumbing to Venus's environmental assault. 23 minutes of transmission from a planet that had been destroying Soviet spacecraft for nearly a decade. Those 23 minutes cost approximately the equivalent of several $100 million in modern currency. Venus was proving to be the most expensive tourist destination in human history. The real breakthrough came with Venera 9 and 10 in 1975. These heavily armored spacecraft managed to survive long enough to transmit the first photographs from Venus's surface. The images revealed a hellish landscape of flat rocks under dim orange skies. The probes lasted 53 and 65 minutes respectively before Venus finally claimed them. Each photograph cost roughly the price of a small city's annual budget. Later Venera missions pushed survival times to over 2 hours by using increasingly creative engineering solutions, thick titanium pressure vessels, internal cooling systems, corrosion-resistant electronics. The Soviets basically built spacecraft submarines designed to survive on the surface of hell. Venus had forced human engineering to its absolute limits, just to take a few pictures and measurements before inevitable destruction. The Soviet Venus program represents one of the most expensive trial and error experiments in space exploration history. Dozens of spacecraft, decades of development, billions of rubles spent learning that Venus destroys human technology with ruthless efficiency. Yet those brief moments of successful data transmission revealed more about Venus in a few hours than centuries of telescopic observation from Earth. Sometimes the most hostile environments teach us the most valuable lessons, even if they charge astronomical tuition fees for the privilege. Consider the cosmic odds. Out of thousands of discovered worlds, only our planet managed to win the ultimate triple jackpot: liquid water oceans, breathable oxygen atmosphere, and a protective magnetic field. This combination is so rare. Despite decades of searching with billion-dollar space telescopes, astronomers have found exactly 0 other worlds with all 3 winning numbers. Let's start with liquid water, the universe's most demanding chemical. Water only stays liquid within an incredibly narrow temperature range. Too cold and it becomes useless ice. Too hot and evaporates into space forever. Earth maintains vast oceans of liquid water covering 71% of its surface for over 3.8 billion years straight. That's longer than most stars exist before burning out completely. The oxygen atmosphere represents an even more miraculous achievement. Oxygen is chemically reactive stuff that disappears quickly, unless something continuously replenishes it. Earth's atmosphere contains 21% oxygen only because living organisms have been manufacturing it through photosynthesis for billions of years. Without life constantly producing oxygen, our atmosphere would lose this essential gas within a few million years. Earth's breathable air exists only because life created and maintains it. The magnetic field provides Earth's invisible superpower. Our planet generates a powerful magnetic bubble extending 60,000 kilometers into space. This magnetic shield deflects deadly solar radiation and cosmic rays, rays that would otherwise strip away our atmosphere and sterilize the surface. Mars lost its magnetic field billions of years ago and became a frozen wasteland. Venus never developed strong magnetic protection and became a toxic furnace. But here's what makes Earth's triple jackpot truly extraordinary. These three features work together in perfect cooperation. The magnetic field protects the atmosphere from solar wind. The atmosphere maintains stable temperatures for liquid water. Liquid water enables life to exist. Life produces oxygen to maintain the atmosphere. It's a self-reinforcing system of planetary teamwork, one that has operated flawlessly for billions of years. Consider the alternatives. Venus has thick atmosphere but no magnetic field, plus surface temperatures that boil water instantly. Mars has weak magnetic field, thin atmosphere, and frozen water. Europa has liquid water under ice but no breathable atmosphere or magnetic protection. Thousands of exoplanets have been discovered with one or two of these features. Earth alone scored the cosmic trifecta that makes complex life possible. We're living on the universe's only confirmed miracle planet. Earth measures about 8,000 miles in diameter. Not too big like the gas giants that crush everything under massive gravity. Not too small like Mars that can't hold on to a decent atmosphere. Just the right size to create a world that looks gorgeous from space, while remaining perfectly livable on the surface. Our planet nailed the cosmic Goldilocks test for planetary proportions. From space, Earth appears as the solar system's most stunning resident, a brilliant blue marble swirled with white clouds and brown continents. Floating in the black void, no other world in our cosmic neighborhood displays such vibrant colors. Mars looks like rusty orange sandpaper. Venus hides under featureless yellowish clouds. Jupiter and Saturn show interesting bands but lack solid surfaces. Earth alone developed the colorful beauty that makes astronauts weep when they see it from orbit. The blue comes from our vast liquid oceans reflecting and scattering sunlight. Earth's oceans contain 1.4 billion cubic kilometers of water. That's enough to cover the entire planet under 2.7 kilometers of liquid, if the surface were perfectly smooth. No other known planet maintains such extensive surface water. Earth essentially operates as the universe's only confirmed water world with dry land. Those swirling white clouds create Earth's dynamic weather patterns visible from space. Our atmosphere moves heat and moisture around the globe, in constantly changing patterns that create beautiful spiral storms, cloud formations, and weather fronts. Earth's weather system operates like a global heat engine, powered by solar energy and driven by planetary rotation. The result is atmospheric artwork that changes daily. The brown and green continents add the final touch to Earth's cosmic portrait. Our planet's surface features dramatic mountain ranges, vast forests, sprawling deserts, and winding rivers, all visible from orbit. Earth developed complex geography through 4.6 billion years of geological activity. No other world displays such diverse and beautiful surface features, combined with abundant liquid water and swirling atmospheric dynamics. Earth's physical dimensions also create perfect living conditions. Our planet's size generates enough gravity to hold onto a thick atmosphere, but not so much gravity that it crushes surface features or traps excessive gas. Earth's 24-hour rotation period creates reasonable day-night cycles. Without extreme temperature swings, The planet has an axial tilt of 23.5 degrees. That generates mild seasons, seasons that vary climate gradually rather than dramatically. Earth got planetary engineering exactly right. Earth enjoys the solar system's most reliable cosmic babysitter. Our moon doesn't just create pretty nighttime lighting and ocean tides. This oversized satellite serves as Earth's gravitational stabilizer, preventing our planet from tumbling into the chaotic climate swings that would make complex life impossible. Without the moon's steady influence, Earth would wobble like a cosmic spinning top, losing its balance. The moon's gravitational pull keeps Earth's rotational axis locked at a stable 23.5-degree tilt. This consistent tilt angle creates Earth's mild seasonal cycles that gradually shift climate zones without dramatic extremes. Mars lacks a large stabilizing moon, and its rotational axis wobbles wildly over geological time. Sometimes Mars tilts only 10 degrees, creating minimal seasons. Other times it tilts 60 degrees, causing extreme climate chaos, where polar ice caps melt completely and reform at different locations. Imagine Earth without lunar stabilization. Our planet's axial tilt would vary randomly between 0 and 85 degrees over thousands of years. Sometimes the poles would point directly at the sun, creating scorching polar summers and frozen equatorial regions. Other times Earth would spin upright with no seasons at all. Climate zones would shift unpredictably, making long-term biological adaptation nearly impossible. The moon also created Earth's 24-hour day through tidal breaking. Early Earth spun much faster, with days lasting only 6 hours. The moon's gravitational pull on Earth's oceans created tidal bulges that gradually slowed our planet's rotation to its current comfortable pace. Without this lunar braking system, Earth would still spin rapidly. With extreme weather patterns caused by powerful atmospheric circulation, tidal forces provide another essential service. The moon's gravity creates ocean tides that mix nutrients, prevent stagnation, and may have helped early life transition from sea to land. Tidal pools serve as natural laboratories where complex chemistry can develop under varying conditions. Some scientists believe lunar tides played a crucial role in the origin of life. By creating the right mixture of wet and dry conditions for organic chemistry, the moon formed through a massive impact that blasted material from early Earth into orbit. This cosmic collision created the largest moon relative to planet size in the inner solar system. Earth and Moon essentially function as a double planet system, with gravitational interactions that benefit both worlds. Earth gets climate stability while the Moon gets protection from asteroids and comets. Within Earth's gravitational influence, it's the solar system's most successful cosmic partnership. Earth operates the universe's most ambitious home renovation project, while other planets display ancient surfaces that haven't changed in billions of years. Earth constantly tears up and rebuilds its entire exterior through plate tectonics. Our planet functions like a geological perfectionist, one that can never leave its surface decoration alone for more than a few million years. The secret lies beneath our feet. Earth's outer shell consists of massive rocky plates floating on a partially molten interior. These tectonic plates move at speeds of 2 to 10 centimeters per year, roughly the rate your fingernails grow. That sounds slow until you realize that over geological time, this patient movement completely reshapes continents, creates mountain ranges, and recycles ocean floors. At mid-ocean ridges, new seafloor forms as plates separate. Molten rock wells up from deep within Earth, picture underwater assembly lines manufacturing brand new planetary surface. At a rate of several centimeters per year, the mid-Atlantic ridge has been spreading the Atlantic Ocean wider for 200 million years, gradually separating the Americas from Europe and Africa at the speed of growing fingernails. Meanwhile, at subduction zones, old oceanic plates dive back into Earth's interior to be recycled. The Pacific Ring of Fire marks where oceanic plates plunge beneath continental plates, creating volcanic chains and earthquake zones. Earth essentially operates cosmic recycling centers that process old surface material and manufacture new crust, in an endless cycle of geological renewal. This constant surface makeover creates Earth's dynamic geography. The Himalayas continue rising as the Indian Plate pushes into Eurasia. The San Andreas Fault slides California northward along the Pacific Plate. The Hawaiian Islands formed as the Pacific Plate moved over a stationary volcanic hotspot, creating a chain of islands like stamps from a geological assembly line. No other planet maintains this level of surface activity. Venus developed crust too thick for plate movement. Mars cooled down and locked its surface into geological paralysis billions of years ago. Earth alone mastered the art of continuous surface renovation through plate tectonics. Our planet has been redecorating itself for over 3 billion years with no signs of stopping. This geological restlessness constantly creates new habitats, mixes nutrients, and maintains the chemical cycles that make life possible. After decades of searching with increasingly powerful telescopes and space probes, humanity has discovered thousands of exoplanets orbiting distant stars. We've found worlds made of diamond, planets that rain glass sideways, ocean moons that might harbor primitive life. Yet despite all this cosmic exploration, Earth remains the only confirmed address in the universe, where life not only exists but has thrown an evolutionary party, lasting 3.8 billion years. Earth doesn't just host life, it showcases biological creativity that would make the universe's best science fiction writers jealous. Our planet developed creatures that breathe underwater, fly through the air, burrow through solid rock. They survive in boiling hot springs and thrive in frozen Antarctica. Life on Earth mastered every possible ecological niche, inventing survival strategies for environments ranging from ocean depths to mountain peaks. The statistics of Earth's biological success are mind-boggling. Scientists estimate our planet hosts between 8 and 100 million different species. That's millions of unique biological experiments operating simultaneously on the same world. Earth's biosphere includes organisms that photosynthesize sunlight, chemically process rocks, eat toxic waste, and survive radiation levels that would sterilize most known materials. What makes Earth's biological uniqueness even more remarkable is longevity. Life has continuously existed on our planet for at least 3.8 billion years. That's roughly 1/4 of the universe's entire existence. Through cosmic impacts that vaporized oceans, ice ages that froze the planet solid, and volcanic eruptions that darkened skies for decades, life on Earth never completely disappeared. Something always survived to restart biological evolution. Earth's life also transformed the planet itself. Early photosynthetic organisms pumped oxygen into the atmosphere, creating the air we breathe today. Plants and animals shaped the landscape through their activities. Coral reefs built massive underwater structures. Forests modified weather patterns. Life didn't just adapt to Earth's conditions, it actively changed planetary conditions. to make Earth even more suitable for life. The search for extraterrestrial life continues with increasing sophistication. The James Webb Space Telescope analyzes atmospheric compositions of distant exoplanets. Mars rovers search for signs of ancient microbial life. Space probes investigate the subsurface oceans of Europa and Enceladus. Yet despite billions of dollars spent on this cosmic detective work, Earth maintains its status as the universe's only confirmed address where life decided to not just visit, but permanently move in and redecorate the entire neighborhood. Mars operates the solar system's largest iron oxide production facility. This planetary rust factory has been coating itself in reddish dust for billions of years, creating the distinctive color that earned it the nickname Red Planet. The rusty appearance comes from iron-rich rocks and soil, rocks that have been slowly oxidizing in Mars's thin atmosphere, essentially turning the entire world into a cosmic version of a junkyard, full of rusted metal. The red coloration starts with Mars's iron-heavy composition. Early in its formation, Mars accumulated significant amounts of iron throughout its crust and surface rocks. Unlike Earth, where plate tectonics constantly recycle surface materials, Mars preserved this iron-rich geology on its surface for billions of years. The planet essentially became a massive collection of iron-bearing rocks, waiting to rust under the right conditions. Mars's thin atmosphere provides just enough oxygen to enable slow oxidation of surface iron. The process works exactly like rust formation on Earth, but spread across an entire planet over geological time. Iron atoms in Martian rocks combine with oxygen atoms in the atmosphere to form iron oxide, the same reddish compound that creates rust on abandoned cars or garden tools left outside too long. Massive dust storms distribute this rusty material across Mars's entire surface. These planetary sandblasters can engulf the entire world in reddish dust clouds, clouds that last for months. The storms grind iron oxide particles into extremely fine powder and spread it globally, coating everything in a uniform rusty patina. Even areas that weren't originally iron-rich eventually get painted red by airborne dust from distant regions. The red appearance becomes so dominant it's visible through telescopes from Earth. Ancient civilizations noticed Mars's distinctive bloody coloration. They named it after gods of war and violence. The planet's rusty hue made it stand out dramatically against the white, yellow, and bluish colors of other planets visible to naked eye observation. Mars essentially advertises its iron oxide coating across interplanetary space. This cosmic rust coating affects more than just appearance. The iron oxide dust gets into everything on Mars's surface, creating challenges for rovers and future human missions. The fine particles clog mechanical systems, coat solar panels, and create potential health hazards. If inhaled, Mars transformed its distinctive red coloration from a simple geological curiosity into a practical engineering problem that complicates all surface operations. Behold the solar system's most ridiculous volcano. Olympus Mons towers 13.6 miles above the surrounding plains, nearly 3 times taller than Mount Everest. This volcanic monster covers an area roughly the size of Arizona. It rises so gradually, if you started climbing from its base, you wouldn't realize you were on a mountain until you were already halfway to space. How does a planet smaller than Earth create such a massive volcanic structure? Mars lacks the plate tectonics that constantly move volcanic hotspots around on Earth. Hawaiian volcanoes grow large because they sit over stationary hotspots, while the Pacific plate moves overhead, creating chains of islands. On Mars, volcanic hotspots stay in the same location for hundreds of millions of years, allowing individual volcanoes to grow to absolutely ridiculous proportions. Olympus Mons represents the result of volcanic construction projects that lasted longer than complex life has existed on Earth. This mountain accumulated lava flows for over 350 million years, without moving away from its magma source. Layer upon layer of volcanic material slowly built up the most massive mountain in the known solar system. It's like having a construction crew that never takes breaks and never gets reassigned to different projects for hundreds of millions of years. The volcano's base stretches 370 miles across. You could fit the entire state of Colorado inside Olympus Mons' footprint, with room to spare. Despite its enormous height, the mountain's slopes angle so gently that the incline averages only 5 degrees. Walking up Olympus Mons would feel like climbing a very long, very gradual hill that happens to extend into the upper atmosphere. Mars hosts an entire region of giant volcanoes called the Tharsis Volcanic Province. Olympus Mons serves as the largest member of this volcanic family, but its neighboring peaks also dwarf anything on Earth. The entire Tharsis region bulges upward from Mars's surface, like a planetary tumor caused by massive volcanic activity. This geological activity may have been so intense it actually shifted Mars's entire rotational axis over geological time. These volcanic giants are probably extinct now. Mars cooled down billions of years ago as its smaller size allowed internal heat to escape more efficiently than Earth's. But during their active periods, these volcanoes may have pumped enough gas into Mars's atmosphere to temporarily thicken it and warm the climate. The same volcanic activity that created the solar system's largest mountains might have also created brief periods when Mars could have supported liquid water on its surface. Mars operates the solar system's most extensive museum of dried-up waterways. Across its surface lie the fossilized remains of ancient rivers, lake beds, and flood plains. They tell the story of a very different planet. 3.5 billion years ago, Mars may have looked more like Earth than the frozen desert we see today, a world where liquid water carved landscapes and possibly supported the chemistry needed for life. The evidence for ancient water flows covers Mars like a geological crime scene. Orbital photographs reveal countless dried riverbeds snaking across the Martian landscape. These ancient channels show the same meandering patterns, branching networks, and delta formations that characterize rivers on Earth. Some dried valleys stretch for hundreds of miles, indicating massive water flows that persisted for long periods. Impact craters provide additional clues about Mars's watery past. Many craters show signs of water erosion around their rims, and evidence of ancient lakes that once filled their interiors. Some crater lakes were large enough to overflow their boundaries, creating spillways that carved channels through crater walls. These features indicate that liquid water persisted on Mars's surface long enough to fill massive basins and overflow them repeatedly. The most dramatic evidence comes from catastrophic flood channels larger than anything on Earth. These enormous scars suggest that Mars occasionally released vast amounts of liquid water in geological flash floods. The largest flood channels could have carried water volumes exceeding all of Earth's rivers combined. These floods may have originated from underground aquifers that periodically broke through to the surface. Mars rovers have confirmed the presence of minerals that only form in liquid water. hematite, gypsum, and clays discovered by surface missions require water chemistry to form. Some of these minerals show evidence of formation in hot springs or hydrothermal environments, where life could have originated. The chemical signatures strongly suggest that early Mars not only had liquid water, but had it under conditions suitable for organic chemistry. This ancient water history raises tantalizing questions about possible Martian life. If Mars had rivers, lakes, and hot springs billions of years ago, did it also develop microorganisms? Did life emerge independently on Mars like it did on Earth? Are there fossilized remains of ancient Martian organisms waiting to be discovered? The red planet may have been the solar system's second living world, before losing its water to space and becoming the frozen desert we explore today. Mars keeps the solar system's most mismatched pair of moons in its gravitational employment. Phobos and Deimos look less like proper moons, and more like space potatoes that got captured by Mars's gravity during a cosmic game of catch. These lumpy, irregularly shaped satellites represent what happens when a planet settles for whatever leftover space debris happens to be available for moon duty. Phobos, the larger and inner moon, measures only 17 miles across at its widest point. This cosmic potato orbits so close to Mars it completes 3 full trips around the planet every Martian day. From Mars's surface, Phobos would appear to race across the sky, rising in the west and setting in the east due to its rapid orbital motion. The moon moves so fast it would complete its transit from horizon to horizon in just over 4 hours. Deimos, the outer moon, stretches only 9 miles across. It looks even more like a misshapen asteroid than its companion. This tiny satellite takes 30 hours to orbit Mars, moving so slowly across the Martian sky that it would appear nearly stationary from the surface. Deimos is so small and distant that it would look more like a bright star than a proper moon to any hypothetical Martian observer. Both moons probably started as asteroids wandering through the inner solar system before Mars's gravity captured them into permanent service. Their irregular shapes, dark surfaces, and compositions match asteroids found in the asteroid belt between Mars and Jupiter. Mars essentially recruited these cosmic wanderers to serve as its moons when they drifted too close to escape. The gravitational relationship between Mars and its moons creates some interesting future scenarios. Phobos orbits so close to Mars that tidal forces are gradually pulling it inward. In about 50 million years, Phobos will either crash into Mars's surface or break apart into a ring system around the planet. Deimos, meanwhile, slowly drifts away from Mars and will eventually escape into independent orbit around the Sun. These potato-shaped moons make Mars's satellite system look improvised compared to Earth's large, spherical moon. While Earth enjoys a proper moon that creates significant tides and stabilizes planetary rotation, Mars settled for 2 small irregular rocks that barely qualify as satellites. The Martian moon system represents a cosmic compromise between having no moons at all and having something that actually looks like it belongs in orbit around a planet. Mars has earned the distinction of becoming humanity's most serious candidate for planetary real estate expansion, despite being a frozen desert with toxic soil and an atmosphere that would instantly kill unprotected humans. Mars somehow represents our best option for establishing a second home in the solar system. This says something profound about just how hostile the universe is to human life. What makes Mars the least terrible choice for colonization? Location, Location. Mars sits within reasonable traveling distance from Earth. Using current rocket technology, a trip to Mars takes 6 to 9 months depending on orbital alignment. Manageable for human crews. Venus would cook colonists to death instantly. The gas giant moons orbit so far away that travel times stretch to decades. Mars offers the closest thing to a reasonable commute in our cosmic neighborhood. Mars also provides essential raw materials for sustaining human settlements. The planet contains water ice at poles and underground throughout much of the surface. Carbon dioxide in the atmosphere could be processed into oxygen for breathing, and methane for rocket fuel. Iron oxide covering the surface could be refined into metal for construction materials. Mars essentially offers a cosmic hardware store for industrious colonists willing to do their own manufacturing. The Martian day length nearly matches Earth's 24-hour cycle, making it easier for human circadian rhythms to adapt. Seasons on Mars last roughly twice as long as Earth's seasons, but follow similar patterns due to the planet's axial tilt. Mars even has polar ice caps that advance and retreat seasonally, like Earth's polar regions. These familiar patterns could help human psychology adjust to living on an alien world. However, Mars colonization faces enormous challenges that make current plans seem wildly optimistic. The planet's atmosphere provides essentially no protection from cosmic radiation that would gradually damage human DNA. Martian soil contains toxic chemicals called perchlorates that would poison colonists. Dust storms could last for months and would interfere with solar power systems. The low atmospheric pressure means that without a pressure suit, human blood would literally boil. Despite these obstacles, multiple space agencies and private companies are actively developing Mars colonization plans. Space wants to establish a permanent human settlement. NASA plans crewed missions in the 2030s. The appeal of becoming a multiplanetary species drives continued investment in Mars exploration technology. Mars may be a hostile frozen desert, but it's our hostile frozen desert neighbor with the best potential for supporting human civilization beyond Earth. Jupiter reigns as the undisputed heavyweight champion of our solar system. This planetary sumo wrestler weighs more than all other planets combined. It could contain 1,300 Earths inside its massive frame without breaking a sweat. If Earth is a marble, Jupiter is a basketball sitting in the same cosmic neighborhood. This gas giant doesn't just dominate the outer solar system. It essentially owns everything beyond the asteroid belt through pure gravitational bullying. The numbers behind Jupiter's cosmic obesity are genuinely ridiculous. Jupiter contains 2.5 times more mass than every other planet, moon, asteroid, and comet in our solar system added together. If you could somehow place Jupiter on one side of a cosmic scale and everything else on the other side, Jupiter would slam down like a planetary heavyweight, while the rest of our cosmic neighborhood floats up like cosmic feathers. Jupiter's diameter stretches about 89,000 miles across, 11 times wider than Earth. If Earth were a quarter, Jupiter would be a dinner plate. The volume comparison becomes even more absurd. Jupiter's interior could accommodate 1,321 Earth-sized planets, with room left over for a few hundred more. This gas giant essentially functions as a planetary storage unit that could warehouse every rocky world in the inner solar system. But here's what makes Jupiter's size truly extraordinary. Despite being a gas giant with no solid surface, Jupiter's gravitational influence reaches across the entire outer solar system. The planet's massive gravity shepherds asteroid orbits, captures comets, and influences the paths of every object beyond Mars. Jupiter operates like a gravitational traffic cop, directing cosmic movement across billions of cubic miles of space. Jupiter's immense size also affects the entire solar system's stability. Without Jupiter's gravitational presence, asteroid and comet orbits would become chaotic. Earth would face bombardment from space rocks that currently get swept up by Jupiter's gravitational vacuum cleaner effect. Our gas giant neighbor essentially serves as the solar system's cosmic bodyguard, using its massive size to protect smaller planets from celestial violence. The planet rotates faster than any other world in our solar system. Despite its enormous bulk, Jupiter completes one rotation in just under 10 hours, spinning so rapidly that its equatorial diameter stretches noticeably wider than its polar diameter. This rapid rotation creates powerful atmospheric circulation patterns that drive Jupiter's distinctive banded appearance and create the most dynamic weather systems in the known universe. Jupiter hosts the solar system's most persistent weather tantrum. The Great Red Spot represents a hurricane so massive it could contain 3 Earth-sized planets inside its swirling winds. This atmospheric monster has been raging continuously for over 400 years, without showing any signs of calming down. Earth's most powerful hurricanes last for days or weeks before running out of energy. Jupiter's Great Red Spot has been throwing its meteorological fit since before the telescope was invented. The storm measures roughly 10,000 miles across and 5,000 miles tall. That's larger than Earth's entire diameter in both directions. Wind speeds within the Great Red Spot reach 300 miles per hour, fast enough to level cities and turn skyscrapers into projectiles. These winds have been circulating in the same direction for centuries, creating a rotating atmospheric engine that shows no signs of mechanical failure. What keeps this cosmic tantrum running for so long? Jupiter's rapid rotation and lack of solid surface create perfect conditions for persistent storm systems. On Earth, hurricanes weaken when they encounter land masses that disrupt their circulation patterns. Jupiter has no continents, mountains, or solid barriers to interrupt atmospheric flow. The Great Red Spot essentially operates in a frictionless environment, where nothing can stop its spinning motion. Jupiter's atmospheric chemistry adds exotic elements to this weather phenomenon. The Great Red Spot's distinctive reddish coloration probably comes from complex organic compounds created by solar radiation interacting with Jupiter's atmospheric gases. The storm essentially manufactures its own cosmic makeup through ongoing chemical reactions powered by sunlight and atmospheric pressure. The Great Red Spot also demonstrates remarkable stability despite its enormous size and energy. Telescopic observations from the 1600s show the storm maintaining roughly the same position and appearance across centuries. Earth's weather systems change dramatically over much shorter time periods. Jupiter's atmospheric giant has been sitting in approximately the same location longer than the United States has existed as a country. Recent spacecraft observations suggest the Great Red Spot may be slowly shrinking. Historical measurements indicate the storm was larger in previous centuries, possibly spanning an area that could have contained 4 or 5 Earths. Climate change on Jupiter appears to operate on geological time scales, where major atmospheric features evolve over hundreds of years, rather than decades like Earth's changing weather patterns. Jupiter operates the most impressive moon collection in the solar system. This gas giant currently employs 95 confirmed satellites in its gravitational workforce, ranging from major moon superstars to tiny irregular rocks that barely qualify for satellite status. Jupiter essentially functions as a miniature solar system, with its own complex orbital mechanics, tidal interactions, and gravitational politics that rival the complexity of planetary systems around other stars. The four largest moons, Europa, Ganymede, and Callisto, represent Jupiter's main satellite attractions. Galileo discovered these massive moons in 1610 with his early telescope, proving that not everything in the universe orbits Earth. These four worlds are large enough to be planets in their own right, if they orbited the Sun independently. Ganymede actually measures larger than Mercury, and would rank as the solar system's largest planet if it weren't gravitationally enslaved to Jupiter. Serves as Jupiter's most volcanically active employee. This moon experiences such intense gravitational squeezing from Jupiter and its neighboring moons that its interior stays molten despite being located far from the Sun. Operates hundreds of active volcanoes that spew sulfur compounds into space, creating a thin atmosphere and painting the moon's surface in brilliant yellows and oranges. Jupiter essentially turned one of its moons into a cosmic pizza, covered with sulfur pepperoni. Europa hides a liquid ocean beneath its icy surface, an ocean that contains twice as much water as all Earth's oceans combined. Jupiter's gravitational tides keep Europa's subsurface ocean liquid. Despite the moon's frozen exterior, this hidden ocean might harbor more water-based life than Earth itself. Europa represents one of the most promising locations in the solar system for finding extraterrestrial organisms, making Jupiter the potential landlord of alien tenants. Ganymede claims the distinction of being the only moon in the solar system with its own magnetic field. This massive satellite also shows evidence of subsurface oceans like Europa. Callisto displays the most heavily cratered surface in the solar system, preserving impact scars dating back billions of years. These four major moons alone offer more geological diversity than most planetary systems. Jupiter's gravitational influence extends far beyond its major satellites. The planet captures asteroids and comets into irregular orbits, gradually adding to its moon collection over cosmic time. Some of Jupiter's tiny outer moons probably started as independent objects, before wandering too close to Jupiter's gravitational territory. The gas giant essentially operates a cosmic recruitment program that continuously expands its satellite empire. Jupiter moonlights as the solar system's most effective cosmic janitor. This gravitational giant spends its time vacuuming up dangerous asteroids and comets that might otherwise devastate inner planets like Earth. Without Jupiter's protective services, our planet would face bombardment from space rocks that could trigger mass extinctions on a regular basis. Jupiter essentially operates as Earth's unpaid bodyguard, using gravitational muscle to redirect cosmic threats. The asteroid belt between Mars and Jupiter provides perfect examples of Jupiter's gravitational housekeeping. This rocky debris field contains millions of asteroids that could potentially threaten Earth if their orbits became destabilized. Jupiter's massive gravity keeps most asteroid belt residents locked in stable orbits that prevent them from wandering toward the inner solar system. The gas giant functions like a gravitational fence that contains dangerous space rocks in a cosmic pasture. Jupiter also captures comets from the outer solar system, before they can approach Earth. These icy visitors from beyond Neptune occasionally fall toward the inner solar system, where their melting could create spectacular displays or devastating impacts. Jupiter's gravity deflects many comets into harmless orbits, or captures them permanently as new satellites. The planet essentially operates a cosmic security checkpoint that screens incoming visitors from interstellar space. Historical evidence demonstrates Jupiter's protective effectiveness. In 1994, astronomers watched as comet Shoemaker-Levy 9 collided with Jupiter in a series of spectacular explosions. The impacts created temporary dark spots larger than Earth and released energy equivalent to millions of nuclear weapons. If that comet had hit Earth instead of Jupiter, it would have caused global catastrophe. Jupiter took the cosmic bullet that could have sterilized our planet. Computer simulations show that without Jupiter's gravitational protection, Earth would experience major asteroid impacts, roughly 1,000 times more frequently. These impacts would make complex life evolution nearly impossible. By constantly resetting biological development through mass extinction events, Jupiter's presence allows life on Earth to develop over billions of years, without constant interruption from cosmic catastrophes. However, Jupiter occasionally redirects objects toward the inner solar system rather than capturing them. The planet's complex gravitational influences can sometimes send asteroids or comets on Earth-crossing trajectories. Jupiter operates more like a cosmic traffic director than a perfect shield, sometimes routing dangerous objects away from Earth and occasionally directing them toward us. Overall, though, Jupiter's protective benefits far outweigh its occasional misdirections. In the cosmic security business, Jupiter operates the solar system's most confusing real estate market. This planetary giant offers plenty of space, but absolutely no solid ground for landing. Jupiter consists almost entirely of hydrogen and helium gas, compressed under its own enormous gravitational weight. Trying to visit Jupiter's surface would be like trying to land on a cloud. There's simply no air there to stand on. The planet's atmospheric composition reads like a simplified chemistry textbook. Jupiter contains roughly 89% hydrogen and 10% helium, with trace amounts of methane, ammonia, and water vapor. These are the same basic ingredients that form the Sun, making Jupiter essentially a failed star that never grew massive enough to ignite nuclear fusion. If Jupiter had accumulated about 80 times more material during planetary formation, it would have become a second star in our solar system. As you descend into Jupiter's atmosphere, the gas gradually becomes denser and hotter due to increasing pressure. Scientists estimate that somewhere deep inside Jupiter, the hydrogen becomes so compressed it transforms into liquid metallic hydrogen, a bizarre state of matter that doesn't exist naturally anywhere on Earth. This liquid metal core might be what generates Jupiter's powerful magnetic field. Through electrical currents flowing within the compressed hydrogen, Jupiter may contain a solid rocky core buried beneath thousands of miles of compressed gas and liquid. Recent spacecraft data suggests this core might be larger and more diffuse than previously expected, possibly resembling a fuzzy rock formation rather than a distinct solid boundary. The extreme pressure and temperature conditions deep inside Jupiter create an alien environment, where familiar materials behave in completely unfamiliar ways. The lack of solid surface makes Jupiter impossible to explore using traditional landing missions. Spacecraft entering Jupiter's atmosphere would gradually descend through increasingly dense gas until pressure and temperature destroy them long before reaching any solid material. The Galileo probe survived for 58 minutes while descending into Jupiter's atmosphere in 1995, before being crushed and melted by conditions that exceeded the probe's design limits. Jupiter's gaseous nature also creates the most dynamic and colorful atmospheric displays in the solar system. The planet's rapid rotation and complex chemistry generate distinctive bands of clouds in various shades of brown, white, red, and orange. These atmospheric features constantly change and evolve like a planetary kaleidoscope. Jupiter essentially functions as a massive atmospheric laboratory, where weather patterns operate on scales impossible anywhere else in our cosmic neighborhood. Saturn runs the universe's most successful jewelry business. This planetary fashion model wears the most spectacular ring system in the known cosmos. It makes every other world look sadly underdressed by comparison. While other planets settled for boring solid surfaces or plain gas balls, Saturn decided to accessorize, with millions of ice chunks arranged in perfectly organized cosmic bling that stretches thousands of miles into space. The ring system contains countless individual particles. They range from dust grains to house-sized boulders, all composed primarily of water ice mixed with rocky debris. These cosmic gemstones orbit Saturn in paper-thin sheets. They span over 170,000 miles from edge to edge, but measure only about 30 feet thick in most places. Imagine a compact disk scaled up to the size of a football field, while maintaining the same proportional thickness. That's how remarkably flat Saturn's rings appear. Each ring particle follows its own independent orbit around Saturn, like a miniature moon. The particles closer to Saturn move faster than those farther out. This creates the appearance of solid rotating disks when viewed from a distance. In reality, Saturn's rings resemble a cosmic traffic system. Billions of ice chunks cruise around the planet in perfectly organized lanes. They move at different speeds. The rings display intricate structure visible through telescopes as distinct bands. They are separated by gaps. The most prominent gap, called the Cassini division, stretches 3,000 miles wide. It results from gravitational interactions with Saturn's moons. These shepherd moons act like cosmic traffic cops. Their gravity keeps ring particles organized in specific orbital zones. It also prevents them from spreading chaotically throughout Saturn's vicinity. Saturn's ring system probably formed from the destruction of a moon or large asteroid. It wandered too close to the planet. Tidal forces ripped apart the unfortunate victim. Then they scattered its remains into countless orbiting fragments. Over millions of years, these debris pieces spread into the magnificent ring structure we observe today. Saturn essentially turned a cosmic catastrophe into the solar system's most beautiful piece of planetary jewelry. The rings create constantly changing visual displays as Saturn orbits the Sun. When Earth aligns with the ring plane, Saturn's rings appear edge-on and nearly disappear from view. Despite their enormous width, 6 months later, the rings present their full glory as spectacular arcs of light. Surrounding the planet, Saturn performs a slow cosmic fashion show. It takes 29 Earth years to complete one full cycle of ring orientations. Saturn earned the distinction of being the solar system's least dense planet. This cosmic lightweight champion weighs so little relative to its enormous size that it would float like a giant beach ball if you could find a bathtub large enough to hold it. Saturn's average density measures only 0.69 grams per cubic centimeter. less dense than liquid water, which clocks in at 1.0 grams per cubic centimeter. How does a planet larger than 760 Earths manage to weigh so little? Saturn consists almost entirely of the lightest elements in the universe, hydrogen and helium. These gases make up roughly 96% of Saturn's composition. Hydrogen accounts for about 75%. Helium contributes another 21%. The remaining 4% includes trace amounts of methane, ammonia, and other compounds. They add flavor to Saturn's atmospheric recipe without contributing significant mass. Saturn's low density creates some remarkable physics. The planet's rapid 10.7-hour rotation day generates such powerful centrifugal forces that Saturn bulges noticeably at its equator. The planet appears visibly flattened when viewed through telescopes. Its equatorial diameter measures about 8% larger than its polar diameter. Saturn spins so fast it literally stretches itself into an oblate shape, like a cosmic balloon being squeezed at the poles. This lightweight construction affects Saturn's gravitational influence on its surroundings. Despite being the second largest planet in our solar system, Saturn's low density means it generates weaker surface gravity than much smaller but denser worlds. Standing on Saturn's cloud tops would feel similar to standing on Earth, even though you'd be on a planet nearly 10 times wider than our home world. Saturn's fluffy composition also explains why the planet displays less dramatic atmospheric features than Jupiter. The lower density creates gentler pressure gradients and more subdued weather patterns. Saturn's storms and cloud bands appear more pastel and muted, compared to Jupiter's bold atmospheric displays. This gas giant shows elegance over drama in its atmospheric fashion choices. The extreme lightweight nature makes Saturn unique among gas giants. Jupiter, Uranus, and Neptune all contain significantly more heavy elements, mixed with their hydrogen and helium. Saturn represents the purest example of a gas giant, built from cosmic leftovers after rocky planet formation consumed most of the heavy elements. In our solar system's early history, Saturn employs the solar system's most overqualified moon. Titan measures 3,200 miles in diameter. It is larger than Mercury. It is second only to Jupiter's Ganymede among planetary satellites. This massive moon does not just orbit Saturn. It operates its own complex weather system complete with thick atmosphere, seasonal cycles, and liquid lakes that would make any planet jealous of its atmospheric sophistication. Titan's atmosphere actually outperforms many planets in thickness and complexity. The Moon maintains surface atmospheric pressure 1.5 times greater than Earth's, dense enough to support weather patterns and protect the surface from space radiation. Unlike most moons that exist as airless rocky balls, Titan wrapped itself in a substantial atmospheric blanket. It is composed primarily of nitrogen with traces of methane and other organic compounds. The methane in Titan's atmosphere creates the most exotic weather system in our solar system. Methane evaporates from surface lakes, rises into the atmosphere, condenses into clouds, and falls back down as methane rain. This alien water cycle operates at temperatures around minus 290 degrees Fahrenheit, where methane behaves like water does on Earth. Titan essentially runs Earth like weather patterns using completely different chemistry. Lakes of liquid methane and ethane cover portions of Titan's surface, particularly around the North Polar region. These hydrocarbon lakes range from small ponds to massive seas, larger than the Great Lakes combined. The largest, called Kraken Mare, spans over 150,000 square miles and contains more liquid hydrocarbons than all of Earth's oil reserves. Titan transformed into a cosmic gas station, with oceans of fuel floating on its surface. Beneath Titan's exotic surface lies an even more remarkable secret. Scientists suspect that a liquid water ocean exists deep underground, beneath the Moon's icy crust. This subsurface ocean might contain more water than all of Earth's oceans combined. It could potentially harbor life forms adapted to the dark, cold conditions. Titan offers both surface hydrocarbon chemistry and underground water chemistry in the same fascinating package. Titan's thick atmosphere creates a greenhouse effect that helps maintain liquid methane on the surface. Despite the Moon's great distance from the Sun, the atmospheric haze gives Titan its distinctive orange appearance. It completely obscures surface features when viewed with visible light. Only radar and infrared observations can penetrate the atmospheric murk to reveal the alien landscapes hidden beneath Titan's smoggy veil. Enceladus operates the solar system's most spectacular water fountain show. This small icy moon, measuring only 13 miles in diameter, shoots massive geysers of water vapor and ice particles. Hundreds of miles into space from fractures near its south pole, NASA's Cassini spacecraft discovered this cosmic sprinkler system in 2005. It revealed that tiny Enceladus hides one of the most active geological processes in our planetary neighborhood. The water geysers erupt from parallel fractures nicknamed tiger stripes. They stretch across Enceladus's south polar region. These mysterious cracks in the Moon's icy surface appear darker and warmer than surrounding terrain. They indicate active geological processes heating the subsurface. The tiger stripes essentially function as cosmic plumbing. They tap into underground water reservoirs and vent them dramatically into space. What powers these impressive water eruptions on such a small world? Saturn's gravitational tides squeeze and flex Enceladus as the Moon follows its elliptical orbit. This generates internal heat through tidal friction. The same forces that create ocean tides on Earth heat Enceladus's interior, enough to maintain liquid water beneath its frozen surface. This tidal heating makes Enceladus one of the most geologically active moons in the solar system, despite its diminutive size. The water geysers contain more than just pure H2O. Chemical analysis of the erupted material reveals dissolved salts, organic compounds, and tiny silicate particles. They suggest interaction between liquid water and rocky materials deep inside Enceladus. These ingredients indicate that the Moon's subsurface ocean makes direct contact with a rocky core. This creates the chemical conditions that could potentially support microbial life. Enceladus's geysers feed Saturn's outermost ring with fresh ice particles. This creates a continuous supply of ring material. The Moon essentially operates as a cosmic ice machine. It replenishes Saturn's ring system. It also provides evidence for one of the most promising locations to search for extraterrestrial life. In our solar system, this small icy world proves that spectacular geological activity does not require planetary-sized mass. The discovery of Enceladus's water geysers revolutionized astrobiology. It revealed that small icy moons can maintain the liquid water necessary for life. Before Cassini's observations, scientists focused primarily on Mars and Europa as the most promising places to search for life beyond Earth. Enceladus demonstrated that Saturn's moon system might harbor the ingredients for biology in an underground ocean that shoots samples of itself directly into space for easy scientific analysis. the Cassini spacecraft conducted the most comprehensive planetary surveillance operation in space exploration history. For 13 years, this robotic investigator orbited Saturn. It transmitted over 450,000 photographs and countless scientific measurements. These revolutionized our understanding of the ringed planet and its diverse moon collection. Cassini essentially served as humanity's embedded reporter in the Saturn system. It sent back exclusive coverage of cosmic phenomena that no Earth-based telescope could ever detect. Cassini's ring discoveries alone rewrote textbooks about Saturn's famous accessories. The spacecraft revealed that Saturn's rings contain structures called spokes, mysterious dark features that rotate with the rings. They appear to form through electrical interactions with charged particles. Cassini also discovered tiny shepherd moons embedded within the rings. They sculpt ring particles into intricate braided patterns. They maintain sharp ring edges through gravitational shepherding. The mission's moon discoveries proved even more spectacular. Cassini's close encounters with Enceladus revealed the water geysers. These made this small moon one of the prime candidates for harboring extraterrestrial life. The spacecraft flew through Enceladus's geyser plumes multiple times. It analyzed their chemical composition. It confirmed the presence of a global subsurface ocean. Cassini essentially discovered an alien ocean by flying through its spray. Titan became Cassini's most studied target, with over 120 close flybys that mapped the moon's surface. Beneath its thick atmospheric haze, the spacecraft deployed a probe called Huygens that landed directly on Titan's surface in 2005. It provided the first close-up images of this alien world's methane lakes and hydrocarbon landscapes. Cassini and Huygens revealed that Titan operates Earth like geological processes, using completely different chemistry. Saturn itself provided numerous surprises during Cassini's long surveillance mission. The spacecraft discovered massive hexagonal storm patterns at Saturn's North Pole. It observed lightning storms in the planet's atmosphere. It measured variations in Saturn's magnetic field. These revealed information about the planet's internal structure. Cassini showed that Saturn remains far more dynamic and mysterious than previous missions had suggested. The mission concluded in 2017 with Cassini's deliberate destruction in Saturn's atmosphere. This was to prevent contamination of potentially habitable moons like Enceladus. The spacecraft transmitted data until its final moments. As it burned up in Saturn's clouds, it provided a dramatic conclusion to one of the most successful planetary exploration missions ever launched. Cassini's 13-year investigation of Saturn created a scientific legacy that will inform future missions to the ringed planet for decades to come. Something went seriously wrong with Uranus during planetary formation. While every other planet spins upright like proper cosmic citizens, Uranus decided to lie down on its side and roll through space like a wayward bowling ball. This planetary oddball tilts 98 degrees from vertical, meaning it essentially orbits the Sun while lying on its side. Imagine Earth suddenly flipping so the North Pole points directly at the Sun. That's Uranus's everyday reality. This sideways orientation creates the most bizarre seasonal patterns in the known universe. For 21 Earth years, Uranus's North Pole faces the Sun in permanent daylight, while the South Pole experiences continuous darkness. Then the planet slowly rotates, and its equator faces the Sun for a brief period, before the South Pole takes its turn basking in solar radiation for another 21 years. Each hemisphere experiences 42 years of summer followed by 42 years of winter. What caused Uranus to become such a cosmic contrarian? Astronomers suspect that early in the solar system's violent history, Uranus suffered a catastrophic collision with another planetary-sized object. This cosmic car crash apparently knocked Uranus completely sideways and left it spinning in the wrong orientation ever since. The planet has been rolling through space like a knocked-over top for over 4 billion years, without bothering to right itself. The sideways rotation affects more than just seasonal cycles. Uranus's magnetic field also tilts at a crazy angle. It is offset about 59 degrees from the planet's rotational axis. Most planets align their magnetic fields roughly with their rotation, like Earth's magnetic North Pole sitting near the geographic North Pole. Uranus's magnetic field points in completely the wrong direction, as if the planet's internal compass got scrambled during that ancient cosmic collision. Uranus's moons and rings also follow the planet's sideways orientation. They orbit around Uranus's equator like rings around a cosmic barrel lying on its side. When viewed from Earth, Uranus's ring system sometimes appears as concentric circles. Other times it appears as a straight line. This depends on our viewing angle as Uranus tumbles through its 84-year orbit around the Sun. This topsy-turvy rotation makes Uranus the solar system's most disoriented resident. The planet essentially gave up trying to spin properly after getting knocked sideways billions of years ago. Uranus proves that sometimes cosmic accidents create permanent personality disorders. They last for geological ages. This planetary oddball reminds us that not every world follows the standard rules of cosmic behavior. Uranus operates the solar system's most effective deep freezer. This ice giant maintains surface temperatures around -370 degrees Fahrenheit. It makes Uranus colder than Neptune despite being closer to the Sun. At these extreme temperatures, Uranus makes Antarctica's worst winter day feel like a tropical vacation. The planet essentially functions as a cosmic refrigerator that never gets unplugged. The beautiful blue-green coloration comes from methane gas in Uranus's atmosphere. Methane molecules absorb red light while reflecting blue and green wavelengths back to space. This gives Uranus its distinctive aquamarine appearance. This atmospheric makeup creates a world that looks like a giant marble, made of frozen tropical ocean water floating in the cosmic darkness beyond Saturn. Uranus's atmosphere consists primarily of hydrogen and helium like other gas giants, but it contains higher concentrations of water, methane, and ammonia ices. These ices do not exist as frozen solids at Uranus's distance from the Sun. Instead, they form thick, slushy layers under extreme pressure deep within the planet's interior. Uranus essentially operates as a cosmic slushy machine, manufacturing exotic forms of ice under conditions impossible to recreate on Earth. The extreme cold affects everything about Uranus's behavior. The planet radiates almost no excess heat from its interior. Unlike Jupiter, Saturn, and Neptune, which all glow with internal warmth from leftover formation energy or radioactive decay, Uranus appears to have completely cooled down internally. It becomes a cosmic cold storage unit that barely generates any heat beyond what it receives from the distant Sun. Weather patterns on Uranus remain largely mysterious due to the planet's extreme distance and bland atmospheric appearance. Unlike Jupiter's dramatic cloud bands or Saturn's beautiful storm systems, Uranus displays a remarkably featureless atmosphere. It appears almost uniformly blue-green. The planet's weather operates like meteorological wallpaper, probably active but too subtle to observe clearly from Earth-based telescopes. The methane in Uranus's atmosphere creates the most extreme greenhouse effect in reverse. While methane typically traps heat like on Venus or Titan, the tiny amounts of solar energy reaching Uranus are not sufficient for significant atmospheric warming. Methane essentially decorates Uranus with beautiful blue coloration. It does nothing to prevent the planet from becoming the solar system's most stylish icebox. Neptune defies every rule about planetary weather systems. This distant ice giant generates winds reaching 1,200 miles per hour, fast enough to circumnavigate Earth in less than 21 hours. These supersonic atmospheric hurricanes make Earth's most powerful tornadoes look like gentle breezes. Neptune essentially runs a cosmic wind tunnel that never turns off its fans. How does a planet so far from the Sun generate such violent weather? Neptune receives 1,000 times less solar energy than Earth. Yet it somehow manufactures the most extreme atmospheric dynamics in the solar system. The planet's internal heat source provides the energy for these spectacular wind systems. Neptune radiates 2.6 times more energy than it receives from the Sun. This indicates powerful internal processes that drive atmospheric circulation. Neptune's most famous atmospheric feature was the Great Dark Spot, a massive storm system larger than Earth that Voyager 2 discovered in 1989. This cosmic hurricane displayed wind speeds reaching 1,500 miles per hour around its edges, the fastest winds ever measured in the solar system. The Great Dark Spot functioned like Neptune's version of Jupiter's Great Red Spot, but with even more violent atmospheric circulation. Strangely, when the Hubble Space Telescope observed Neptune several years later, the Great Dark Spot had completely disappeared. Neptune apparently operates disposable storm systems. They form and dissolve over periods of just a few years. The planet creates massive atmospheric hurricanes, runs them at maximum intensity for a while, then discards them, and builds new ones in different locations. The extreme wind speeds occur despite Neptune's incredible distance from the Sun. At 30 times Earth's distance from our star, Neptune receives solar energy so weak that high noon feels like deep twilight. Yet this energy-starved world generates atmospheric violence that dwarfs weather patterns on planets much closer to solar heating. Neptune proves that internal planetary heat can create more dramatic weather than solar energy. Neptune's atmospheric composition resembles Uranus, but with more dynamic activity. Both planets contain hydrogen, helium, and methane. But Neptune's stronger internal heat source creates the violent mixing that generates visible storm systems and cloud formations. Neptune essentially took the same atmospheric ingredients as Uranus and turned them into a cosmic weather catastrophe that operates in permanent overdrive mode. Uranus and Neptune occupy the solar system's most remote suburbs. These ice giants live so far from the Sun that solar energy arrives with the intensity of a dying flashlight. Uranus orbits 19 times farther from the Sun than Earth, while Neptune sits 30 times more distant than our home planet. At these extreme ranges, the Sun appears as little more than a bright star in their alien's gaze. The distances involved challenge human comprehension. Light from the Sun takes 2 hours and 40 minutes to reach Uranus, compared to just 8 minutes and 20 seconds to reach Earth. Neptune sits so far away that sunlight requires over 4 hours to complete its journey from our star. These planets receive news from the Sun with a significant time delay, like cosmic correspondence that takes hours to deliver. Solar energy becomes pathetically weak at these distances. Uranus receives only 0.25% of the solar energy that reaches Earth. Neptune gets even less, just 0.1% of Earth's solar input. High noon on these worlds provides less illumination than Earth experiences during a total solar eclipse. Both planets exist in permanent cosmic twilight, where the sun barely provides enough light to cast shadows. The extreme distances make spacecraft missions to these worlds incredibly challenging. Voyager 2 took 12 years to reach Neptune after launching from Earth in 1977. Modern spacecraft using current technology would require similar travel times to visit these distant worlds. The ice giants essentially exist in a different neighborhood of the solar system, where quick visits are impossible. Communication delays with spacecraft exploring these distant worlds create operational nightmares. Radio signals from Earth take over 4 hours to reach Neptune. This means mission controllers cannot provide real-time guidance to spacecraft operations. Any spacecraft visiting Neptune must operate autonomously for hours while waiting for commands from Earth. It's like trying to drive a car by remote control, with a 4-hour delay between pressing the gas pedal and seeing the car respond. The isolation affects everything about these worlds. Their moons and ring systems formed in cosmic exile, far from the gravitational influences that shaped the inner solar system. Uranus and Neptune rep what happens when planets develop in the cold, dark outskirts of stellar influence. Strange worlds that barely qualify as members of our Sun's planetary family. Voyager 2 achieved the most impressive road trip in space exploration history. This robotic explorer became the only human-made object to visit Uranus and Neptune. It conducted the equivalent of a cosmic cross-country tour that spanned 12 years and covered over 4 billion miles. Voyager 2 essentially served as humanity's sole ambassador to the ice giants. It gathered the only close-up information we possess about these distant worlds. The spacecraft launched in 1977 during a rare planetary alignment. This occurs once every 75 years. This cosmic coincidence allowed Voyager 2 to use gravitational assists from Jupiter and Saturn. It reached the outer ice giants with 1970s rocket technology. Without this lucky celestial geometry, visiting Uranus and Neptune would have required much larger rockets, or much longer travel times. Voyager 2 caught the solar system's ultimate cosmic taxi service. Voyager's encounter with Uranus in 1986 provided the first detailed observations of this sideways spinning world. The spacecraft discovered new moons, mapped the planet's tilted magnetic field, and confirmed Uranus's bizarre rotational orientation. Voyager 2 revealed that Uranus operates even more strangely than astronomers had suspected. The planet proved to be weirder up close than it appeared from a distance. The Neptune encounter in 1989 delivered even more spectacular discoveries. Voyager 2 found the Great Dark Spot Storm System. It measured Neptune's incredible wind speeds. It also discovered that this distant world radiates more energy than it receives from the Sun. The spacecraft's photographs showed Neptune as a dynamic, active planet, despite its extreme distance from solar heating. Voyager 2 revealed Neptune as the solar system's most unexpectedly violent weather machine. Voyager 2 also discovered previously unknown moons around both ice giants. It provided detailed observations of their magnetic fields, atmospheric composition, and ring systems. The spacecraft gathered more scientific data about Uranus and Neptune during its brief flybys than centuries of Earth-based telescopic observations had achieved. Voyager 2 essentially wrote the textbooks about ice giant planets. during a few days of close encounters. After completing its grand tour of the outer planets, Voyager 2 continued traveling toward interstellar space. The spacecraft now operates as humanity's most distant active probe. It sends back data about the boundary between our solar system and the cosmic void beyond. Voyager 2 transformed from an ice giant explorer into an interstellar pioneer. It carries human knowledge to regions where the sun's influence finally ends, and true space